In this problem, a shopper pushes a grocery cart 20 meters at constant speed on level ground against a 35 Newton frictional force. He pushes in a direction 25 degrees below the horizontal. What is the work done on the cart by friction? Okay, so let's do a diagram. Here's the cart. We'll draw it without wheels. And the friction force is 35 newtons in this direction. It's 35 newtons. And the cart, the displacement is 20 meters in that direction, and our shopper is pushing down with a force F 25 degrees below the horizontal. So what is the work done by friction? The work done by friction is FD cosine 180 degrees. The angle between the friction force and the displacement vector is 180 degrees. Okay, so, and cosine 180 is -1, so the work done by friction force is always negative. And so this is 35 newtons times 30 meters. Okay. Okay, that's the work done by the friction force. And then part B, what is the work done on the cart by the gravitational force? So part B, so here's the cart, and that's the direction in which and the force of gravity is that. The angle between the two is 90 degrees. The work done by gravity is force of gravity times d times cosine 90, and cosine 90 is 0. So gravity does 0 work. What is the, let's add a page. Part C says, what is the work done on the cart by the shopper? Okay, so here's the shopping cart, and here's the force that the shopper applies. There's the displacement of the cart. This angle is 25 degrees, so the work done by the shopper. Oh, okay. Alright, now actually, so we have to, here's the friction force, we have to do the following. Here's the weight, here's the normal force, okay, and they tell us that velocity is constant. So we're going to use the work energy theorem to find the work done by the force. The net work done is equal to change in kinetic energy. So final kinetic energy minus initial kinetic energy. And since the velocities are constant, final kinetic energy is equal to that, so this is 0. And the net work done is the work done by friction force, work done by gravity, plus work done by the normal force, plus work done by the force. And that should equal to 0. Now we saw that the work done by gravity is 0. Work done by gravity is 0 because this force is perpendicular to the displacement. Well, the normal force is also perpendicular to the displacement, so work done by the normal force is also 0. So work done by the shopper is equal to negative of the work done by friction force, which is negative 1050 joules. Okay. what is the work done on the cart by the shopper. So we found the work done. Now we'll need to find the force the shopper exerts using energy considerations. And what is the total work done on the cart? Oh, we already stated it. All right, so okay, so we've already stated from the net work kinetic energy theorem, since the kinetic energy does not change, the net work done is 0, which is what we used in part C. Okay, let's do part D. Find the force the shopper exerts using energy considerations. Well, we already have calculated the work done, so we can calculate the work done. We know the work done is FD cosine 25 because the angle between D and F is 25 degrees. And we know that this is 1050 joules. So the force is 1050 joules divided by D cosine 25. So this is 1050, 30 meters, cosine 25, and this works out to 38.6 newtons. Okay, so that's the magnitude of the force that the shopper exerts. Okay, I think that takes care of all this problem. So what is this problem? 29.